Now that you've been introduced to the information that you can find on the periodic table of the elements, this video will look at how the periodic table organizes elements based on their characteristics and based on which other elements share similar properties and atomic structures to them. Now, it should be noted from the previous video that the most critical number in order to understanding periodic table organization is, of course, the atomic number. So all elements are sorted in numerical order based on their atomic number. So hydrogen has an atomic number of 1, so it is the first element. Helium, as we read from left to right, has the atomic number of 2, so it's element number 2, and then we simply drop down to the second row here where we find lithium's atomic number, which is 3, and so on and so on and so on. Now, the reason why we use the atomic number to organize elements is because this tells us a critical feature, that being the number of protons that each element has. And as we see, as we increase the number of protons from hydrogen to helium, the element becomes different. So the distinction between one element and another is determined by their number of protons. It should also be noted that the atomic number also tells us the number of electrons as well, but we will be exploring this in subsequent videos. Now, the way that we read the periodic table, we can do this in two different directions. So, when we read from hydrogen to helium, we read from left, or from the far left side of the periodic table to the right-hand side. So we can see, if we read the atomic numbers from left to right, we see that they increase. So if we take a look at row number 2, element number 3 is lithium, element number 4 is beryllium, we skip over here, element number 5 is boron, and so on. So we can see that we read the periodic table in the same direction from left to right, just like we do with reading English. In fact, because we read the periodic table from left to right, so if we read the periodic table horizontally, this is where we get the word periodic from, because the technical term that we give to each row is what we call a period. So the first row is what we call the first period, and the second row, not much of a surprise, is what we call the second period, and as you might guess, the third row is what we call the third period. Now, for those that are wondering, why does the first period only have 2 elements, hydrogen and helium, whereas the second and third row actually have 8 elements that we see here? Well, it's because each of the different rows represents a different electron shell. So remember how in the previous video we looked at how electrons are actually found outside of the nucleus, and depending on the number of electrons an element has, it will have a different number of shells. So for example, hydrogen and helium are found in the first period, and therefore they only have 1 electron shell, whereas lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon in the second period will have 2 electron shells, and this will be explored in the next series of videos where we look at atomic structure in more detail. Now, we can also read the periodic table from top to bottom like this. So if we were to read the periodic table vertically instead, each of these categories of elements are what we call groups, and we can identify the groups by looking at the Roman numerals that we see at the top of each of the groups here. So the group technically speaking, containing lithium, sodium, potassium is Roman numeral 1A, so we would call this group 1. Then the group containing beryllium, magnesium, calcium, etc. has a Roman numeral 2A, so we would call this group 2. We kind of skip over the middle section here, and if we get to the group containing boron, aluminum, gallium, etc., this is Roman numeral 3A, so this would be group 3. And elements are grouped into the same groups because of the similarities in their valence electrons. So remember that valence electrons are the electrons in the electron shell that are farthest away from the nucleus, and this will become a very obvious pattern when we actually take a more detailed look at atomic structures and how the valence shells are organized. Now, the last thing that we're going to do in this video is we're actually going to learn about several more closely related groups of elements, meaning elements that are found in the same vertical columns as each other, because a lot of these elements we can actually group together because they have similar behavior. So the first distinction we see on this periodic table is the color coding. So we can see that all of the elements that are on the left-hand side of this zigzag line here, this isn't exactly halfway in the periodic table, obviously, but this zigzag line here is quite obvious, and you can see pretty much all of the elements that are on the left-hand side of this zigzag line are colored in light green. These are what we call the metals. So if you think of a metal, you probably think of a substance that is flexible. For example, like aluminum, you can bend aluminum foil very easily. You'll also think of metals as being shiny and very good at reflecting light, as most metals are. Now, if we take a more detailed look at the metals, we can see that there are several closely related groups of elements which we call element families based on shared chemical properties. And the first of these is group number 1A. The metals here are what we call the alkali metals, and the alkali metals are fun to talk about because they are some of the most reactive metals that exist. For example, this metal here, well, not really a metal anymore because we see that it's exploding when you put it into water, is the metal potassium. We also see that when it explodes, it burns with a bright pinkish purple flame, which makes it fun in chemistry demonstrations. Now, when we talk about valence electrons, we will see that the reason why alkali metals are so reactive is because they only have one electron in their valence shell. And again, more on this in subsequent videos. If we go immediately to the right of the alkali metals, we get to the alkaline earth metals. Let's put earth in caps there. So the alkaline earth metals are also very, very reactive, although slightly less reactive than alkali metals. If you were to take beryllium, magnesium, or calcium and drop them into water, you wouldn't get a fabulous display, but they are very reactive in their own way. This picture here shows what happens when you light magnesium on fire. It catches fire and burns with a brilliant white light that burns at over 3,000 degrees Celsius. And this bright white light is why we use magnesium to make fireworks. Burning magnesium is responsible for the luminous displays that fireworks create when they explode. Now, one pattern that we'll see is that the group number determines the number of valence electrons that elements have. So the alkali and earth metals, because they're in group 2A, have 2 valence electrons instead of the alkali metals having 1. Now, as we transition, pay attention to that word that we used just now, as we transition from left to right across the periodic table, we cross a group of metals in the center of the periodic table, and I use the word transition very deliberately because these metals in the center of the periodic table are what we call the transition metals, and transition metals are rather unusual compared to the alkali metals and the alkaline earth metals because they have a property called multivalence. which means that unlike the alkali and alkaline earth metals that have a single charge, transition metals actually have the ability to make more than one charge, and this property will be explored in detail in future videos. If we go all the way over to the right-hand side of the periodic table, all of the elements that are not colored in light green, these are going to be our nonmetals, which will also be grouped into several families. So the first family that we're going to look at are the purple-backed elements here that kind of straddle the metal-non-metal dividing line, and for that reason we call these the metalloids, which basically means metal-like or similar to metals. And because these form the dividing line between the true metals and the true non-metals, many of the metalloids are more similar to metals. For example, germanium and antimony are more like metals, while others are definitely more similar to non-metals in terms of their properties, such as boron, silicon, or arsenic. If we go to the far right-hand side of the periodic table, we get to probably the two most interesting families of the periodic table. Group number 7A, or 17 in the Arabic numerals, and Roman numeral 7A here, is a highly reactive family of nonmetals, which are what we call the halogens. And if we remember that the group number determines the number of valence electrons, the halogens being group 7A means that they have 7 valence electrons, and some of the halogens are some of the most dangerous elements that exist. For example, this green gas here is actually chlorine gas, which has been outlawed by the United Nations for its use as a chemical weapon during the First World War, because soldiers that breathed this gas in found themselves violently choking as this gas melted their lungs from the inside out when it reacted with water in order to produce acid that dissolved them from the inside out. And many other halogens also have very dangerous properties to them, which makes them scary to handle but very interesting to study as chemists, which leaves the final group here, what we call group Roman numeral 8A. This is a family of gases that we call the noble gases, which are special, especially compared to halogens, because unlike the halogens, the noble gases are completely unreactive. And some of you may recognize helium here as a gas that you can breathe in that makes your voice sound high-pitched. And of course, if you do this, as long as you get enough oxygen to survive, helium does nothing to you and therefore doesn't pose any risk at all, again, as long as you get enough oxygen. And the noble gases are as unreactive and stable as they are because as group 8A, they have 8 valence electrons, which in subsequent videos we will see means that they have a full valence shell. This concludes our introduction to the structure of an atom and how the periodic table is organized. Before you watch the first videos in the next series, take a look at the practice questions below, which will practice or help you practice identifying elements based on what group or what period they're in, and will also help you see whether you can identify elements as being alkali metals, alkali earth metals, halogens, noble gases, or any other specific family.